For this example, Lammer's Limos offers limousine service from the City Hall in Toledo, Ohio to Metro Airport in Detroit. The president of the company is considering two different routes. One's via US 25 and the other is via Interstate 75. He wants to study the time it takes to drive to the airport using each route and then compare the results. He collected the sample data in the table, which is reported in minutes. So here's our sample data. And our question is, using the 0.10 significance level, is there a difference in the variation in the driving times for the two routes? So first of all, is this what's the first step in the hypothesis test? First step is that we assume that nothing is going on, in which case we refer to the null hypothesis. So we make our null hypothesis statement, which is the population variation, or the variation of population of the first data set, US 25, is equal to the variation of the second data set, the population of the second data set. So the alternate hypothesis then is that they differ, or that they're not the same. Step 2 in the hypothesis testing process is, what is the maximum risk of rejecting a true null hypothesis we are willing to accept? In this case, it's given its 0.10 significance level. And so we determine we're going to use the F distribution, and we use the appendix B4 in your text to find the critical value. And because it's a two-tailed test, we divide the 0.10 significance level in half. Our N for the US 25 route is 7, and we can just look at it and see that for I-75 it's 8. So for our first set, US 25, our degrees of freedom is going to be 6. And for our second set of data, it's going to be 7. We use the 0.05 table, find the intersection between the degrees of freedom for the numerator and the degrees of freedom for the denominator, and we get 3.87. So our critical value is equal to 3.87. So now we use our formula for the F-test statistic for comparing two variances, and it's simply the standard the variance of the sample data for the first set of data over the sample standard deviation for the second set of data, second variation of the second set of data. So we can calculate out our variance, and we use the sample variance here, and I'm including the blank cell, and you'll see why in just a second, so that I can just copy the formula over, and we have the two variances. Now to calculate our F test statistic, we just calculate the larger number divided by the denominator, and we get a value of 4.23 if we were to reduce this down a little bit. Whoop, wrong way. So we took our sample, we got our sample data, we did our sample test statistic, and now we took our sample and how likely was it that we got what we got. And if it's very unlikely, we're going to call baloney on the assumption that nothing's going on. The decision is to reject the null hypothesis because the computed F-test statistic of 4.226 is greater than the F-critical value of F.387. And we conclude that there is a difference in the variation of the travel times along the two routes. Now, what we can do also is we can go into the data analysis toolpack, and of course you have to have the data analysis toolpack set up as an add-in. Click on the F-test for 2 sample for variances, and here we can just put in the ranges, and actually let's go ahead and redo this and include the labels. And we can just put that right over here, since it's not a big space taker. And here you can see that we have our f-test and our f-critical value. And let me just do the calculation using the numbers we had here again to do our f-test statistic. And you can see that our numbers line up with what we got here. If we were to take this and this and drop off a few decimal points, looks to be the same numbers that we had. So that's how you do it in Excel.